So this example was hopefully worked through on your own. So let's walk through it now and see if you were able to correctly come up with the proper steps. So it was a children's game, don't break the ice. Small plastic ice cubes are squeezed into a square frame, yada, 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 yada. Over here, this is the computer output, right? It's called Fathom. It's a computer program. And it summarizes the data taken during a 1 hour sample. It tells you what each line is. So the first line is your mean, so that's our X bar. The next line is our count, which is our sample size, N. The next line is our standard deviation of that sample, and then the standard error of that mean. So do the data provide convincing evidence that the mean is not 29.5? Use the significance test with a 0.05 alpha significance level to find out. So the first thing that we need to do is we need to go through and say our hypotheses as well as identifying the parameter of interest. Also stating the significance level that we want to use, 0.05. Remember, we're using mu here as opposed to X bar, right? We're always testing for a population parameter. Mu here is the true mean width, I should say, of plastic ice cubes. So after you've gone through and you've stated that, then you should come up with your name of the test that you're doing. I'll leave this up there. We're going to perform a one sample t-test for mean. Remember, have all three pieces when you say it. Random. Yes, this was a random sample. In this case, luckily, our sample size is bigger than 30, so central limit theorem says we're good to go, and it's okay for us to use t procedures in this instance. Next, we need to test independent. Safe to assume there are at least 500 cubes produced by this machine each hour. So we're good to go there. Then we have to do some calculations. We end up getting a test statistic t of negative 0.95. Okay. Now, because this is a two-sided test, right? We know it's two-sided because the alternative hypothesis is not equal to. When you're doing this using your calculator, go in the smaller direction. So what I mean by that is that this is negative 0.95 and this is positive 0.95. You want to do the direction that makes the most sense. So negative is to the left, positive would be to the right. And then you just double it. Remember, degrees of freedom is always one less than your sample size. So my degrees of freedom here will be 49. So using your calculator to figure this out, double your value, and you get a p-value of 0.3468. You could have also done this in your calculator. So what this would have looked like in your calculator, if you go to Stat, over to Tests, this is a t-test. Now this is just stats. This is not the actual data. So you have to enter in all the things. So we're claiming 29.5. The sample mean was 29.4943. The sample standard deviation was 0.0877121. Sample size was 50. Two-sided test. Gives me the same things. No, it doesn't. Sorry, everyone. I realized that I made some mistakes in my calculations. I'm not quite sure where, but this is why it's really great to have the calculator to test it to see if you did your math right. So I had put the wrong number. I don't know where I'd gotten that. So this is the correct number of your standard deviation. I don't know what I'd put there. And then I guess I'd done my calculations wrong, and this is your true test statistic, which then leads you to a different value for your p-value, which is 0.6479, which is a very high p-value, if you ask me. So then when you come to your conclusion, even though I'd done my math wrong, I still came to the correct conclusion, because my p-value was actually greater than our alpha. So we're going to fail to reject our null hypothesis, and then we say that there is not enough evidence to conclude that the mean width of cubes produced is not 29.5. Notice how I'm not saying we're saying that the mean is 29.5. We're just saying that I don't know enough to say that it's not 29.5. The verbiage there can be kind of wonky, a little bit confusing, but remember, we never accept the null. We either reject or fail to reject, and then we either say we can conclude our alternative or we can't conclude our alternative. Okay? Alright, the next video is going to talk about this concept of paired data, so stay tuned for the next video.